Hello, welcome back. Algebra 1, lesson 2.4. If you're following along in the module online, this is module 2, page 4. And today we're going to get into solving inequalities. So with inequality, our aim is the exact same as it is when we're solving equations. The difference here being that instead of an equal sign, we're going to have this greater than, less than, or greater than or equal to, or less than or equal to sign. So instead of equals, we have inequalities. And then when you do that, there are some tips you have to follow, some rules you have to follow. If you are ever going to multiply or divide by a negative number, you have to flip your sign. So instead of this one being greater than, it would flip over and become less than if you were to divide or multiply by a negative number. The second rule is if you are to switch the place of the x and the y, say this, for example, the x was on this side and the 10 was on that side. Instead of being greater than now, it's less than. This is x is greater than 10. And this way, if you read it backwards, x is greater than 10, it's still true. So when you flip both sides, you have to flip the sign. It's not like when you have 10 equals x and you just switch x equals 10, okay? With that, you just switch the sides, right? Because the equal sign, when you flip it, it's going to look the same no matter which way it is. When you have an inequality, if you flip sides, the sign also has to flip, okay? So it's if you flip everything on the right side and everything on the left side and you completely flip the equation, you will flip the inequality symbol in the middle as well. Okay, so that's how, those are the two rules that you have to follow when solving inequalities. Everything else stays the same. So some safe things to do. These things are not going to affect the direction of the inequality. If it's greater than, it's going to stay greater than. If it's less than or equal to, it's going to stay less than or equal to. So any subtraction or addition from a number of both sides, that's not going to change the symbol at all. Multiplication or division by a positive number, that's completely safe. You don't have to think about flipping your sign. When you simplify a side, so if you had 4 over 2 or 2 over 4 and you wanted to reduce that down to 1/2, or if you were to combine like terms, any kind of simplification, if you were to distribute something, a number outside of some parentheses, if you were to distribute to what's inside the parentheses, that's simplification. And that doesn't change your inequality. Those are extremely safe things to do. But there are some things that bring change. And when you bring about change, if you know you're about to divide by a negative or multiply by a negative, I suggest you go ahead and flip the sign on the level below it. When you're writing your equation, say you have something like -2 is greater than, -2x is greater than 10. And you know, okay, well, I need to divide by -2 from both sides. The first thing you should do, because I know I just divided by a negative number, is I have to rewrite my equation with the sign flipped. That's the very next thing I do after I write that I'm dividing by a negative number. Okay, then you would, cancel that out and you have x, and 10 divided by -2 is -5. So that's what we mean by flipping the sign. The other thing that brings change is, again, if you wanted to switch where the variable and the answer was located. So if you want to write this, -5 is greater than x. That also brings change. You see how our less than flipped to a greater than. Okay, so let's look at some steps for solving inequalities. The first step we need to do is to add or subtract to isolate the variable term. Then we multiply or divide to solve for the variable. So essentially what that says is, if we're doing PEMDAS again, you're going to add or subtract to isolate the variable term. So if you had 2x plus 3 is greater than 5, you would have to add or subtract 3 in this case, to isolate the variable term by itself, okay? Then you multiply or divide to solve for the variable. So you're essentially undoing everything that's being done to the variable in the opposite order of PEMDAS, right? But you have to pay attention when you do this step right here, the multiplication or division step, because that is where you get into, if there's this negative number, you have to flip your sign, your inequality sign. Now, if your variable is not on the left, I suggest you always flip it, flip the whole inequality, just flip it around, including the sign as your last step, because we're going to see in just a moment when we're graphing, it's going to be a lot easier to keep things, always have stuff going in the same steps, the same system going, the same routine, and that involves having the variable listed first. Okay, so let's look at this example right here. 12 is less than x plus 5. So our first step was to add or subtract to isolate the variable term. So here we have a plus 5, so we need to subtract 5 from both sides, right? So if we subtracted 5 from this, we're going to get 7 is less than x. We subtracted 5 from this side, it went away. Subtracted 5 from this side, got 7. All right, well, I suggest what we do now is take this x and flip it to the other side. So you have x is greater than 7. Okay, so we'll see in just a moment why that is so important. And that's because of graphing. Now, when we come to graphing inequalities, what we just had was we had x is greater than 7. Okay, so when we have x is greater than 7, there's two things we have to have. Say this right here is a number line. Okay, we need to know how to draw the dot on our number line that represents this number 7. Say this is number 7 right here. Okay, so I need to know what kind of dot to put in. Since it's greater than, I'm going to put what's called a hollow dot. So I'm not going to color it in. So if it had an equal sign under it, if it was like this, we would color in this dot and make it whole. Okay, this is a solid dot. When you have a greater than or less than sign, a solid dot. Okay, greater than or less than without the equals or equals to is going to be a hollow dot. Okay, so that's the first step in graphing your inequality. Now, the variable always needs to be on the left side in order for these rules to apply. That's why I said it's important to always have your variable listed first. So if your variable is listed first, it's always easy to figure out which way the arrow is going to point. Okay, you don't have to say, well, if x is greater than 7, okay, I know 9 is over here, I'm going to test it. Okay, so my arrow is going to point this way. Well, if your variable is listed first, the inequality symbol is always pointing the same direction that your arrow will point. Okay, and then you can just verify it by looking, okay, well, 9's over here, that's on the line, it's graphed, so I'm good. So in other words, let's look at another type of inequality right here. Let's say -2 is less than x. Well, what do I have to do first? I have to flip it so that my variable is on the left side in order to graph it. So I'm going to have x is greater than -2. All right, so if this were my number line, I can plot a -2 right here. This does not have an equal sign on the bottom, so I'm going to have a hollow dot right here where -2 is. Okay, that's my hollow dot. I drew it big so you could see. Now, which way is my arrow pointing? My arrow is going to be pointing to the right, since that's the way that my inequality is pointing. So I've got right here an arrow pointing to the right. It's getting bigger. Now we can verify this. Let's pick a number that's going to be over on this side. Let's choose 0. Is 0 greater than -2? Well, it is, so it works out. I'm done. All right. So I've got some practice here for you. I put the rules up here in smaller print. Let me move the camera so you can see it a little bit. I've got the rules right up here for you to look at, and I want you to go ahead and pause the video, and on your notes that you're taking, write these examples, and you can write them in different colored pencils or pens so that you're able to easily see which graph goes with what. Unpause the video when you're ready to continue. All right, so we have here y is less than 5. So let's look up at our rules. Less than means I'm going to have a hollow dot. So let me go ahead and write 5 somewhere on here. I like that one for 5. I'm going to have a hollow dot. My variable is on the left-hand side, so my arrow is going to be pointing in the way in which my line will be graphed. That one was pretty easy. I didn't even have to do any calculations. All I had to do was graph. It was as if this is similar to already having the answer and just having to graph. So that was cool. All right, so let's look at this next one. -3x plus 5 is greater than or equal to 16. Remember, step 1 was to undo any addition or subtraction. So we're going to subtract 5 from both sides, and I'm going to be -3x is greater than or equal to, let's see, 16 minus 5 is 11. Okay, so now what I have to do is undo this -3 here, right? And it's being multiplied by x, so I have to divide. Oh, but that's a negative number. So the very first thing I'm going to do is I'm going to flip my sign. This said greater than or equal to, so I flip my sign to less than or equal to, okay? So I know I'm going to divide by -3 on both sides, -3. So what's left on this side, I have x. What's left on my right side is 11/3. Now I have a single negative, an odd numbered negative, so my answer will be negative. Can I reduce 11/3 at all? No, I can't make that fraction any smaller. But how do I know where it is on the number line? Oh. Well, the easiest way for me to determine where something is on the number line is to see, well, how many times does 3 go into 11? Well, 3 goes into 9 3 times. So 11 divided by 3 is going to be 3, with 9, 10, 11, 2/3 left over. So 3 and 2/3, -3 and 2/3. So if I put, let's say -3 and -2 and -4, -3 and 2/3. I know it's got to be somewhere close to this -3 right here. Well, let's think about it. 2/3 is 0.6 repeating. So -3.66666 is going to be closer to the -4 than it is to the -2. So I'm going to put my dot right about here, just a little bit more than halfway between the -3 and the -4. Now, do I need a solid dot or a hollow dot? Well, let's look. This is going to be less than or equal to, which means I need a solid dot. So I'm going to put in a solid colored dot right there. My variable is in front or on the left side, so I know that my arrow is going to point the same direction as my inequality. And that's my graph. Now, let's move on to number 3. 3x is greater than 10. Well, what's happening to the x? It's being multiplied, but is it being multiplied by a negative? Nope, it's a positive number, so I don't have to do anything. But with my inequality symbol, I don't have to do anything. It's going to stay exactly the same. So x is greater than 10/3. 10/3, I cannot reduce any lower, but 3 goes into 10 3 times with 1 remaining. So 3 and 1/3. So if I've got 3, 4, and 2, 3 and 1/3 is going to be closer to the 4 than it is to the 2. So it's going to be right about here. 1/3 of the way between the two. And I know that I'm going to have a hollow dot because there's no equal sign there. So I'm going to do my hollow dot. And then I can see that because my variable is on the left, the arrow will be pointing the same way as the inequality. So it's going to point that way. I'm trying to make it so you can see my arrow there. Okay. So moving on to number 4. This one is a little more complicated. You see here it says x minus 3 in parentheses divided by 2. Well, that's the same thing as x minus 3 over 2, right? Is less than or equal to -5. Huh. Well, how do I undo this fraction? Well, I undo this fraction is a division symbol. So I undo it by doing multiplication. I'm going to multiply by 2. So here, this is going to cancel out. Here I have -5 divided by 2. So am I multiplying by a negative? Well, that's a good question. Good catch there. But what we're really concerned with is the one that we're undoing, that we're doing to both sides. We didn't multiply by a negative on both sides. This -5 was already here. We are not actually multiplying by -5. The -5 is being multiplied by a +2. So there is no need to flip that sign because what we're undoing is the positive division right here. So we're multiplying by a +2. So it's going to stay exactly the same. So on this side, we have x minus 3 remaining. And on the right side, you have 5 times 2 is 10. And then there's an odd amount of negative symbols. There's only one negative symbol. So my answer is going to be negative. All right, so now what I need to do. Oh, and real quick, I wanted to say that the reason we undid the division before the subtraction is because this is in parentheses. And when I put it as a fraction, the parentheses didn't disappear. They seem to have disappeared, but it's just math magic, right? They're implied. We still have implied parentheses anytime we have a fraction. The numerator is in parentheses. So that is a part of, when we consider PEMDAS, that is a part of the parentheses. The subtraction is in parentheses. So we have to wait and do that last. Going upwards, there is no addition or subtraction that could be undone prior to undoing the multiplication and division. Now there's no exponent. So now we're going to move into what was inside of the parentheses, which is, in this case, addition and subtraction. So I have to add 3 to both sides. So I'm going to be left with x is less than or equal to -10 plus 3. Well, those are two different signs. So I'm going to find the difference. 10 minus 3, 7, 8, 9, 10, that's 7. And the larger number, -10 and +3, is going to carry the sign of the answer. So -7. So x is less than or equal to -7. Now, I have or equal to here. So I know it's going to be a positive, a solid dot. Excuse me, I said positive, a filled in dot, a solid colored dot. And I have my number right here, -7. My x, my variable, is on the left-hand side. So I know that my arrow is going to be pointing the same direction that my inequality is pointing right here. My inequality is pointing to the left, so my arrow is pointing to the left. I hope you all got all of those correct as well. All right, so linear inequalities. We've been writing and solving some linear equations in previous lessons. Now we're going to try to solve some inequalities. These are going to be word problems that we're going to have to figure out what to write. We tried one in our last equation when we were doing our last problem of our last lesson, when we were trying to figure out how many students that teacher could take to Ziggy's Zany Zoo. And so we already practiced this once. We had a little preview, but now we're going to do it again. So before we do it, let's think about some common steps we use for inequalities or even equations. First, we're going to draw a picture if applicable. This usually applies to things that involve geometry. When you're asked about questions with flagpoles or building fences or perimeters and areas of things. So if there's an opportunity to draw a picture to visualize the mathematics that you're doing, go ahead and do that. It always helps. The second is to define our variable. In other words, we have to pick a letter to choose to represent the missing information. It's always easy to plug in an X, but sometimes if we're looking for a number, we might use N. If we're looking for a width, we might use W. If we're looking for the number of students, we might use S. So you get to define your variable when you're the one writing the equation or inequality. So then we need to set up our equation. In this case, we're setting up our inequality. And then you need to solve it. And then you check to make sure, always important with word problems especially, check to make sure you're actually answering the question that was asked of you. Because when we're asked questions like 3 numbers add up to be 72. What is the largest number? Well, if we just solve for n, that wouldn't give us our answer. We need to solve for n plus 2. Okay, so you always check to make sure you have actually answered the question that was asked. So let's continue. I have those steps right up here in the right corner for us to reference as we go through this problem. It says the sum of 2 consecutive integers is less than 83. And we're supposed to find the pair of integers with the greatest sum. The sum of 2 consecutive integers is less than 83. Normally I go straight for the is, right? And I put an equal sign, but in this case is not complete. It's is less than. So I know it's going to be like this, is less than. Well, what is it less than? It's less than 83. So something is less than 83. Well, let's figure out what that something is. The sum, okay, well, I know I'm going to have a plus sign. I'm going to have 2 things I'm going to be adding, right? The sum of 2 consecutive integers is less than 83. Okay, so that's the information that I got out of this. Let's go through these steps now. We're told to, step 1, draw a picture if applicable. Well, we have no picture to draw. Second thing, we're going to define our variable. So we're going to put x as the first consecutive number and x plus 1 as the second consecutive number. So I'm going to plug that in right here, which leads me to the very next step. Determine our equation. X plus 1 is less than 83. Well, you see here, I have in the typed version, I have it in parentheses. So that is the proper way to do it, especially if you're unsure if you're going to be adding or multiplying or if it would change it at all. Once you write it in parentheses, then you can see whether or not you want to keep those parentheses. In this case, we don't need to keep the parentheses because when you're adding something in parentheses, you can just drop the parentheses. It would be different if we had to multiply something in parentheses or subtract or divide. So add is really the only time you can just drop the parentheses. All right, so the next step was to solve the equation. So let's go ahead and do that now. We have the equation x plus 1 is less than 83. Well, we went ahead and dropped the parentheses. Let's combine like terms. We have 2 like terms of x here. My x will stay the same. We have the same letter, same exponent, same letter, same exponent. Let's combine the coefficients. I don't see any coefficients. Well, that doesn't mean there aren't any. We have some implied coefficients here. The implied coefficient before each of these letter x's, each of these variables is the number 1. So in order to combine our coefficients, we add them together. 1 plus 1 is 2. I'm going to cross out the terms I've already used so I don't have to think about them again. And then I don't have anything to combine this plus 1 with here on this side of the equation or inequality. So my expression is complete, 2x plus 1. And then there's nothing to do on this side is less than 83. Now, if I remember back to my steps of what to do to solve inequalities, I know that the first thing I'm going to undo is any addition or subtraction so that I can get the variable term by itself. So if I have the variable term of 2x is being added 1 to it, I know I need to subtract 1 from both sides. So I'm going to have 2x is less than 82. When I subtracted 1 on this side, that term went away. When I subtracted 1 on the right side, it became 82. Okay. Now, the next step is the one that I need to pay attention to the rule. I need to undo any multiplication or division. And if the thing that I'm undoing is a negative number, I'm going to have to remember to flip this sign. So let's look at this. X is being multiplied by a positive 2. So I'm going to undo that by dividing by a positive 2. No sign flipping needed. No flipping of tables. All right, so we've got X here is less than, what's 82 divided by 2? Well, half of 8 is 4, and half of 2 is 1. So X is less than 41. Okay, so we did step 1, step 2, step 3. That was step 4, solve. Now we're going to check to make sure we actually answered the question. So the sum of 2 consecutive integers is less than 83. What's our question? Find the pair of integers with the greatest sum. So the first of the number is an integer that's got to be less than 41. It cannot be equal to 41. It has to be less than 41, right? Because it doesn't say less than or equal to. It simply says less than in this case. So my first integer that's the greatest but less than 41, so it meets all those qualifications, is going to be 40. So X is going to equal 40. So that means the second consecutive number has to be 1 greater than that. So X plus 1 is going to be 41. Now let's check and make sure that these actually add up to 83, which is what we're looking for. 40 plus 41 is 81. Well, that's less than 83. Less than 83. 40 plus 41, 81. 81 less than 83. Checks out. We're good. So our answers 40 and 41 work. If we went to the next one, 41 plus 42, let's see if that works. Because it says we're looking for find the pair of integers with the greatest sum. So 41 plus 42, what was it? That's 83, but that's not less than 83. So that does not work. 83 is not less than 83. Okay. Can you think of a way that if it, a word in English, because this is a word problem that we could have used here if we wanted to get the answers 41 and 42? Well, we could have said, the sum of 2 consecutive integers, which is less than or equal to 83. Okay, so our answers were 40 and 41. Now, here's some practice for us. We're going to go ahead and practice these inequalities and solving. You're supposed to also graph your solution when you're done. So go ahead and pause the video. Let's practice these inequalities. Welcome back. The sum of twice a number and 7. So the sum, I know I'm going to add 2 things. The sum of twice a number, I'm going to put that as 2n, the sum of twice a number, and 7. I'm going to put 7 there. So 2n plus 7 is less than, I use the 7, is less than 27. Okay, 27. Let me erase these lines real quick. Looks like I erased too much. 2n plus 7 is less than 27. All right, write and solve an inequality statement. I already did that. All right, to figure out the constraints on this number. Oh boy, okay. Well, that's a fancy way of saying just figure it out. Figure out the answer and graph your solution. All right, so 2n plus 7 is less than 27. What do we need to do? We need to undo this addition first. So if I subtract 7 from both sides, I'm going to be left with 2n, this cancels out, is less than 20. Now I need to do the division and multiplication undo. Well, if I'm undoing anything with a negative, then I have to flip it. Luckily, this is positive here that I'm going to do to both sides. So I'm left here with n. I do not have to flip my inequality. It's going to stay less than. Okay, 20 divided by 2 is 10. Now it says I need to graph this. Well, I don't have a number line here, so the easiest way for me to graph this is just write it. I know that if it doesn't have equal then underneath it, if it's just less than, I'm going to have a hollow here. My variable is on the left-hand side, so my inequality is pointing the way that my arrow would go. So this is my graph without a number line. If you had a number line, It would look the same, just laid on top of a number line. All right, so moving on, number 2, your quiz grades are 78, 72, 87, and 90. Looks like you took 4 quizzes so far. What score on the 5th quiz will make your average quiz grade at least 82? Well, in order to do this, you need to know how to find an average. How you find an average is you have to add everything up, then divide by how many there are. So let's add these up. 78 plus 72 plus 87 plus 90 plus our 5th quiz grade. Let's call it Z for quiz. Okay, now all of that added up. So the sum of all of those divided by 5 has to equal at least 82. So I'm going to put 82 right here. But let's think about this. Can it be equal to 82? Well, yes, it can. So I'm going to put that equals sign part at the bottom so I know it can at least equal 82. Now, which one is supposed to be greater, my average or the number 82? Well, I want to be my average to be bigger than 82. I would love it if my average could be 100, but I don't think that's going to happen because I didn't make hundreds on those other ones. So maybe I can make an average of 90. I want my average to be greater than 82 or at least equal to 82. So here's my equation or inequality that I have here. Okay, so I'm going to simplify what I can. So in order to do that, I pull out my handy dandy calculator and I'm going to add up the numbers, the constants that I have in this equation. So 78 plus 72 plus 87 plus 90. So I got 327 plus Z divided by 5 is going to be greater than or equal to 82. All right, so now that I've done the simplification process, I have to start solving. Now, when I solve, remember, I'm going to do my PEMDAS. And I'm going to move up PEMDAS. So I start with any addition and subtraction that I can undo first. Well, this addition right here is stuck inside some implied parentheses. So I can't undo that addition and subtraction yet. So let's move on to the multiplication and division. I can undo this divide here, but I have to remember when I do my multiplication and division step, when I undo this, if I'm undoing anything with a negative number, I'm going to have to flip my symbol, my inequality symbol here. So let's look at this. This is a positive 5. Oh, whew, I don't have to flip my inequality. I do not have to remember to do that. So I've got here, my multiplying by 5 will cancel that out. So I'm going to be left with 327 plus Z is greater than or equal to 82 times 5. Oh boy, 82 times 5. Let's see what that is. 410. All right, 410. Now, now my parentheses just dissipate. They disappear. They're no longer implied because it's no longer a part of the fraction there. It's no longer a numerator. So we can go ahead and undo this addition. What's being added to Z is going to be 327. It's a positive number because of the symbol in front of it. There's no symbol here, so it's an implied positive. So in order to undo this, we're going to subtract 327 from both sides. This side will cancel out. I'm going to be left here with a Z that I need to have be greater than or equal to, let's do this, 410 minus 327 equals 83. Whew, that quiz grade is something that is definitely obtainable. If I started with a 78, 72, then I got an 87 and 90, I must really be studying hard and learning this math. So I can easily get an 83 on my next quiz or better. If I get better than an 83, my average will go up past 82. It'll go up higher than that. So the answer to number 2 is I need to achieve a quiz score of 83 on my 5th quiz in order to have my average quiz grade be at least 82. All right, number 3, solve the inequality. Negative 3x plus 7 is greater than 5 minus x. Okay, just like our equations where we have variables on both sides, the first thing we want to do is get all of our variables to the left side and all of our constants to the right side. So we're going to follow the same rules because it's just a matter of addition and subtraction. So I'm going to identify all of my variable terms and all of my constant terms that I'm going to want to move here. Okay, then I'm going to write down the things that didn't change. My negative 3x is going to stay exactly where it was. I'm going to have my greater than 5 is going to stay exactly as it was. So all I did was bring those down. I didn't change anything about those, right? Now, what I am going to change is this positive 7 is going to go, it's going to switch sides. So it needs to switch signs, just like it does in an equation. Remember, the only rules that change for inequalities is the multiplying and dividing of a negative term, right? Or negative number. So if this is plus 7 on the left-hand side, on the right-hand side of the inequality is going to be a minus 7. Now let's look at this x right here. If it's a negative x, because you always look at the symbol in front of it, if it's a negative x on the right-hand side of the inequality and it's moving to the left-hand side of the inequality, it becomes a positive x. Now, let's combine our inequalities. Combine like terms. We have two like terms here, x and x. They have the same letter and the same exponent, an exponent of 1. So I'm just going to go ahead and write x, the same thing, same letter, same exponent. Now I need to combine the coefficients of both of these like terms. I have a coefficient of a negative 3 in this term, and this term has a coefficient of positive 1. So a negative 3 and a positive 1. They have different signs. So I find the difference. The difference between 3 and 1 is going to be 2. Now, is that a positive 2 or a negative 2? We'll have to determine which number that I combined had a greater value, 3 or 1. 3 has a greater value, and its sign was negative. So my answer is going to be negative. Now I have greater than. Negative 2 is greater than 5 minus 7. Well, same thing. I'm combining two numbers that have different signs, so I find the difference. 7 minus 2. 7 minus 5 is going to be 2. Now, which thing that I combined had a greater value, 5 or 7? 7 did, and it was negative. So my answer is going to be negative as well. Now I need to undo what's being done to x. It's being multiplied by a negative. Ding, 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 ding. That means I have a rule I have to follow. Okay, so if I'm dividing by negative 2 on both sides, the first thing I want to do, I'm going to jump over here where I have more room. The first thing I'm going to do is flip my sign. Instead of having a greater than symbol, I want to have a less than symbol. Now, cancel this out and I'm left with an x on the left side of my inequality. Negative 2 divided by negative 2, well, that would cancel out too, but I can't leave this side empty. So what am I going to write there? Negative 2 divided by negative 2 is 1. So solve the inequality. X is less than 1. So now let's graph that. We have a hollow dot here, the number 1, and since my variable is on the left, I know it's going to be graphed like that. You would lay that on top of a number line in order to graph it. Last two questions. Solve this inequality. All right, you can go ahead and pause, find the solution, graph the solution, and then unpause it. And then we also have a word problem here for you to do the same with. First thing we need to do is undo any addition or subtraction to isolate the variable term. So we're going to subtract 3 from both sides. So we've got negative 2x these cancel out, is less than or equal to 5 minus 3 is 2. Okay, now I need to undo the multiplication that's being done to my x. X is being multiplied by, ding, 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 alarms going off, a negative number. So divide by negative 2, negative 2. So that means I have to remember, instead of less than or equal to, I'm going to have greater than or equal to. This is canceled out. I have an x on the right-hand side. 2 divided by negative 2 is going to be a 1. And because I have an odd number, I did not write this well. Let's see if I can write that a little bit better so it's easier to read. I had 2 divided by negative 2. This is from the inequality symbol here. Okay, so 2 divided by 2 is 1, and I have an odd number of negatives, so my answer will be negative. X is greater than or equal to negative 1. Now I have to graph this because I have this line on the bottom, the or equals to. I know it's going to be a solid dot. Okay, my negative 1 is going to be listed right underneath that dot. Then because my variable is on the left-hand side, I know that my arrow is going to be pointing to the right because it's going to be the same way that the inequality is pointing. So there is my graph of my solution. And you would obviously, if you on your paper, you had a number line, you would do that on the number line. All right, so number 5, you have the option between 2 phone plans. All right, so if I know I've got 2 things, I'm going to draw a line right down the middle. I'm going to stop right there. Option A, let's put A here. Option B here. Option A charges $25 a month plus, okay, so $25 plus 10 cents per megabyte of data used. So 1/10, that's 10 cents, 1/10, X. How much? Or option B charges $10. So we'll put A equals. Option B charges $10 a month plus 20 cents of data used plus 0.2x. Or if you don't like decimals, you could put 2/10. All right, so how much data do you have to use to make option A cost less, right? If it's a better option for us, it's going to cost less. So we want A to be less than B. So I'm going to set up an inequality here. And I'm going to say I want 25 plus 1/10. You know what? I'm going to go back to the decimals here. 0.1x. I want to be less than, not equal to, because I want it to be better, not equal to 10 plus 0.2x. The question is, how many minutes do I need to talk in order to get this option to be better? So what I'm looking for is what x would I need to have in order to make this a true statement? All right, so I have I have variables on both sides. So the first thing I need to do is I need to move some of these variables around. I'm going to move my variable from the right to the left, and I'm going to move my constant over here, 25. That's a 25 from the left to the right. So let me go ahead and rewrite that 25. See, 25 plus 1/10 x, 25 plus 0.1x. So I'm running out of room, but let me go ahead and do this. I have 0.1x, 0.1x, 0.1x is less than 10. I did not change any of that information, so I went ahead and just wrote it standard there for you. Then my green is a positive 25, and it's moving from the left-hand side to the right-hand side. So I'm going to write that as a negative 25, okay? My 0.2x is a positive 0.2x. It's moving from the right side to the left side. So I'm going to have negative 0.2x. Oh, but look, that's right next to my 0.1. What am I going to put in between? Well, 0.1, that was positive, right? Wasn't my 0.1 positive? So I should have a plus in between there. Hopefully you're able to see that clearly. Let me rewrite it here in, I'll rewrite it in blue for us. We have negative 0.2x plus 0.1x is less than 10 minus 25. Now, we're going to combine our like terms. We have a like term here and here, x and x. It's the same letter, same exponent. So I'm going to be putting an x here, same letter, same exponent. Now I need to combine the coefficients, a negative 0.2 and a positive 0.1. That means I'm going to have a negative 0.1 if I were to combine those. You can use a calculator to verify. And a 10 minus 25 is going to be a negative 15. Again, use your calculator to verify all of your work, especially important when working with negatives. Now, in order to get x by itself, to let it reveal itself, I have to undo what's being done to it. So it's currently being multiplied by 0.1. So I want to divide by negative 0.1. That's a negative that I'm undoing. So I have to remember, flip my sign, flip my inequality symbol, okay? So 15 divided by negative 0.1. Well, I have a negative and a decimal. My gracious, I'm definitely going to use my calculator. All right, 15 divided by 0.1 gives me 150. I have two negatives here. That's an even number. So my answer is going to be a positive. These cancel out and I have x here. X is greater than 150. So my question was, how much data do you have to use to make option A a better option? So your answer in English would be, I would have to use 150 megabytes of data to make option A be a better deal. And there you go. That's the answer to your question and the end of our lesson on inequalities. We'll see you back for the next lesson in just a moment.